everybody, today we are going to talk about reflections. If you saw something different on Google Classroom yesterday, I got a little overzealous, so I'm going to change that around. So don't worry about that. I'm going to fix it up and it should be okay. But this is the video you're supposed to be watching. Reflections are the second type of transformation we're going to talk about. Yesterday we talked about translations, how we slid them. A reflection is a mirror image, right? If you look in a mirror in the morning or whatever, or maybe when you were little you did the butterfly painting that I did, where you paint half of the paper like a butterfly and then you fold your paper and pull it back apart, and it's a butterfly on both sides, right? It's super cute. That's how a reflection works. We're going to flip, or flip, we'll say. We're going to flip a shape or an angle or a line over. Or maybe you would flip it like this, right? And it's going to kind of just be the reverse image, the flipped image on the other side. Typically, for us, we do just basic reflections, which means we're going to go over the x-axis or y-axis. Now we could reflect over like horizontal or vertical lines. That's really not that bad. Like y equals 2 or x equals 4. We could reflect over that if we wanted to. And in a later thing that we're going to do, you can kind of change that axis of reflection. But in general, our easier ones are just going to be x or y axis. All right? So, what's that going to look like? Well, let me draw my little graph over here. So let's say we had a triangle, right? Easy to deal with triangles. We'll just do that. And our triangle looks like this. And we'll call it triangle A, B, C. And if you're having trouble seeing that, hopefully you're not, but if you are having trouble seeing where those points are, I'll kind of write them out for you here. A is -4, +4. B is at 2, 3. And C is at 2, 1. So we have some rules with reflecting. All right, there's kind of two things that can happen. If I reflect over the x-axis, when I reflect over the x-axis, the rule says you keep the x value change the sign of the y value. So you're going to keep whatever the x value is. You're going to change the sign of the y value. So, not sure how well you'll see orange. We'll find out here soon. -4, 4. Let's say we want to reflect over the y-axis, or over the x-axis here. So reflect x-axis. That's pretty light. Yeah. Change it up. So if I want to reflect over the x-axis, the x value of A is going to stay -4. The y value, it was +4. It's going to change to -4. So my A prime is going to be -4, -4. My B prime, the x is going to stay the same. The y is 3. It's going to change to -3. And then in C prime, same idea. The x stays the same. The y changes its sign. So if you want to see what that graph would look like, -4, -4 down here, 2, -3, and 2, -1. Thanks. Forgive my drawing abilities here. There we go. So this is where you got to be careful here. This is A prime. This is B prime. This is C prime, right? It kind of looks confusing, but you can see that if you fold this over the x-axis, those two should match up perfectly. C on top of C prime, B on top of B prime, A on top of A prime. That's how reflection works. So if I go over the x-axis, the x value stays the same. You change the sign on all the y values. That's it. Likewise, if you guessed it, if I reflect over the y-axis, the same thing kind of happens, right? So if I reflect over the y-axis, y values stay the same. X values change their signs. So the way I always remember it is whatever one you go over is the one that stays the same. Hopefully that can help you out because I feel like that's a pretty easy way to remember it. But whatever you go over, those values stay the same. So let's say we had a triangle with vertices of -5, -7, -8, 4, and 12, -2. And I want to reflect over the y-axis this time. So we'll go over both, right? This time we'll go over y. So that means that if I look at my points, let's call this A, B, C. Make it nice and easy for us, right? So if I look at A, I'm going over y, then y stays the same. -5 is going to change to +5. And that would be A prime. And then I look at B, the y stays the same. The x is -8, it turns to +8. And that's B prime. And then over here at C, the y is going to stay -2. The x is going to turn into -12. That's all you got to do for reflections. It's pretty easy, right? That could lead us into ideas like, what if we reflect over both of them, right? So if I have the shape, I go over the x-axis, then I go over the y-axis. Well, really all you're going to do is change all the signs, right? We just do one at a time. Change the x's, then change all the y's. You're going to end up going to change both of them, which is pretty cool. But reflections are nice, and the most important part of reflections is our shapes are still congruent. In the end, our shapes, all that's going to change is it's a mirror image of what we started with, right? If we think about those triangles I had on the board. It's still the same triangle, I just flipped it over. So the structural integrity of my triangle doesn't change. It just kind of flips. So that's going to be important. Every time we reflect, we are going to have congruent shapes, just like when you translate it. Both of those are going to end in shapes that are exactly congruent to what we started with. I think that's all I got for you. There's some practice, obviously, for homework. We got one more to talk about tomorrow, and then I think we're going to do an activity on Thursday. Switch it up a little bit. All right, cool. I'll see you guys later.